The photo service is working fine. However, recently there have been periodic slowdowns. Users are experiencing delays, and it's taking an increasingly long time for the system to respond with a thumbnail image. Then after some time, it appears to speed up again. What could possibly be the cause of the slowdown, and what can you do to change the design to overcome this problem?
Okay, so let's go back to our photo service. In this case, we have a periodic slowdown, which means that under certain conditions, the service is very slow, but at other times it's fast. So what could be causing this irregularity? What's causing the service itself to slow down? And what can we do to fix it? So the thumbnail service is growing, and this can be seen through the number of thumbnails being generated, which is great. We're starting to get more popularity, but monitoring our log processing shows that there appears to be a slowdown during peak periods, and it can take up to several minutes after submitting a photo for the thumbnail image to be returned. Now, this doesn't really happen, but let's take a fictitious scenario where a company has groups of teams that don't really get along or will blame each other. So, in this case, the web dev team thinks that the problem is the thumbnail application code. Well, guess what? The people who wrote the code, the app dev team, think the problem is in the web server application code because it might not be handling sessions and so on. But there are other teams that were impacted too. The support teams are dealing with user calls, so they're calling and asking for help. The operations team, they don't have a procedure to fix the problem because they're the ones who manage the deployment and the production servers. They're not sure if it's the web team's fault or the apps team's fault, so who's going to fix this? So we need to start by covering the process, and again, it's about fixing problems and not people. It's easy to get into silos and say, you know what, it's not my backyard. Go ahead and deal with it. Well, we really need to make this everybody's problem because we're all cogs that contribute to the greater business as a whole. So the root cause is always going to be systems, processes, or behaviors. It's not going to be people. It's not going to be that particular team and so on. Now, our goal is system stability, and we want to be able to find and fix the core problems. In doing so, we also want to learn to avoid repeating the mistakes. This includes fixing what we can, prevent what we can't, and then handle what can be prevented in the future. Sometimes it can be difficult to get everybody on board with this, but without blaming specific individuals, you can create a more collaborative environment and a more innovative culture. So how do you learn if the process does get fixed? Well, you have to document it. While it might be viewed as a really boring process, and most people complain about having to do it, you always want to create reports. But under what conditions? Well, for starters, anytime an SLO is breached, any incident that requires emergency on call, also if there's a need for follow-up communications. For example, if legal need to explain an outage without revealing the impact or something competitive. There needs to be a clear policy that defines the writing of these reports. Timelines must be specified in terms of how soon after an incident a draft is going to be published, as well as a timeline for completing the report. So writing these reports creates a record of what happened and what was done to fix it. This will be a helpful source of reference in the future if a similar event happens again, so doing these post-mortems should be a mandatory part of your recovery processes. All right, so here's our refresher. We're looking at our photo app service. We have a front-end web server, and we store data on a data storage service, which is Google Cloud Storage. And then the thumbnail server will process that. All right, so let's recap where we are. It's taking minutes to generate thumbnails, so the system is definitely slow. A systematic and logical troubleshooting process has been followed, and the 5 whys have been asked and answered. The conclusion is that the issue is definitely tied to the capacity of the system to generate thumbnails. It's also been established that it isn't the front-end web service causing the delays, but the back-end thumbnail generating service, which is failing to keep up with demand. When we say capacity, it's the capacity to actually perform the service in a timely manner. So what happens? The thumbnail is running out of CPU. Now, we could watch CPU utilization, but CPU utilization isn't linear, and during busy utilization times, it can go to 100%. This is sure to impact the end-to-end response time for the user. So how do you monitor it? How do you alert on this? You need to be able to look at specific windows, depending on how long it should be for the average thumbnail to respond. Instead of looking over 5 minutes, maybe you need to look over a minute. But keep in mind, CPU utilization is not actually to be used as a service level indicator. So here was our decision. We decided that if we need to handle more thumbnail processing, it's got to become more scalable. However, we didn't choose to simply throw more CPU and network at it because it was more of a single point of failure. Instead, we decided to add a load balancer and scale out the number of thumbnail servers. The great thing is that it's like a microservice in itself now. Because storage has been isolated to Google Cloud Storage, the same code can be distributed and it doesn't keep track of a queue or anything else. The upload server basically pulls whatever is on the data storage server and it load balances it as they come in. Technically, this is probably an internal load balancer, but we'll get into that a little bit later. In this case, to help us with our greater than 80% CPU utilization, we want to distribute traffic requests from our business logic to the application servers in a cluster. Even though we've added a cluster of servers, we haven't changed anything that our users can measure. The performance is still a measure of the end-to-end latency, and the accuracy of the service is still based on the error logs.